All right, so we are in Algebra 1. Today's date is Tuesday, April 30th. Our last day in April 2019. Go for it, Colby. Or not Colby, Gunner. All right, so 16-6, completing the square. As I said earlier, completing the square is super important once we go into geometry and start talking about circles. All right, so the box method. This was a warm-up, so another chance to prove that you know how to do it for the warm-up. If you have sunglasses, please take them off. Use the box method to multiply these two things together. I need someone to just help me set it up, Andres.
Wait, I just need the XP. So, so
Don't give
on the
him
very top. Or yeah, wait, can we start from there? Yeah, so put X and then plus 7 to know that it's a positive, and then do X plus 7.
Thank you, Andres. You can turn in your card now. I can come over here to, there's our current unit. Andres, you now get the XP. And then what do I do next for the box method, Eder?
X squared.
X squared.
The bottom 7x.
The bottom is 7x.
49.
49. 7x. There it is. Yeah, thank you, Eder. And then I need someone to finally add all of these things together. Again, I multiplied. Eder just multiplied for us. Andre set it up. I need someone to add all of the stuff that Eder just multiplied. Who can do that, Josie?
X squared plus 14x plus 49.
Everyone write it down in your notes. Make sure you have it. Thank you, Josie. And you can turn in your card as well. All right, so now we're starting to complete the square. So completing the square is doing the box method backwards. Write it down. It's completing the square is doing the box method backwards. So instead of starting with x plus 7 and x plus 7, we're going to start with x squared plus 14x plus 49. The next step is to put it in the multiplied area. Then we have to figure out what the sides are. And then finally we'll hopefully get back to this answer. So that's just verbally what to do. Here are the actual instructions. So fill in the box, or the square, I guess. I consider this gray area right here. It's going to be a square because x plus 7 and x plus 7 are the same thing. This is the same thing as writing x plus 7 quantity squared, right, Gunnar? Thank you. All right. So this is really going to be a square because it's the same length on the side, same length on the side. I know we haven't taken geometry yet, but I think if same length by same length at a 90-degree angle, that is considered a square. All right, so we are going to find what of the box next. I just said it. So all I did right now is I took this stuff, I filled it in here. What do I do next if I'm going backwards? I'm going to do the what. What have I not circled in this box yet? I'm going to find the what of the box, and it starts with an S, to give you a hint. Andres, go for it.
Square root. Square.
These things, what do I call those things?
Terms.
I'll give you XP for trying. Sides.
Oh.
Sides of the box, yep. All right, and I'm going to come back to step 3 and step 4, but for now let's do step 1 and step 2 on example number 1. Let's just play with step 1 and step 2. So I'm trying to find the missing constant in the term, and I'm having this perfect square that starts with x squared minus 14x, and then it's going to be something right here, like plus 5, plus 9, minus 13. Something is going to go here. I need to figure out what that number is to complete the square. We'll see here. So fill in the square with what we know. Everyone right now create a box. It doesn't have to be a perfect square, it can be a rectangle. So there's my rectangle. I can draw it a little bit neater. And then cut it in half one way, cut it in half the other way. There is our perfect square ready to go. We just need to fill in things. I just did half of step 1. Who can do the second half of step 1? I need to fill in what we know. Here's x squared minus 14x. That has to go somewhere. And notice that on this box, the 14x was distributed half here, half of this 14 is 7x, half of the 14 is 7x, so I had to distribute it evenly, this 14x. So let's see if someone can do that. You want to go for it, Fernando?
So x on the top. Oh wait.
Let's fill in the inside of this box right here
Oh, the inside.
with these terms right here. So where does this x squared term go?
In the first box.
Yeah, the first box, x squared, top left, okay.
And then -7.
-7 where? Right here?
No.
Bottom left, top right,
Top right.
top right, -7.
And then +7 on the bottom.
And
Oh wait, actually no, it'd be negative.
-7 as well. All right, you're halfway there. Again, you're forgetting this term right here. Pay attention to 14x turned into a 7.
7x.
All right, so this is going to be -7x, -7x. All right, that's all I'm looking for. Thank you, Fernando. Everyone write this down, and I'm going to review what we just did. So we put x squared, Fernando put x squared correctly in the top left because that logically should be where the x squared place goes. It's always in the top left. The hard part is knowing that the -14x, I have to divide that by 2. -14x divided by 2 is -7x. I equally distribute the -7x, or I guess equally distribute this -14x between the top right and the bottom left squares. Nod your heads, just be like, yes, I'm following Mr. Snell, we're good so far. All right, that was step number 2. Ask me questions. We're halfway done with completing the square. Sergio.
Could it be like -10x -4x?
Oh yeah, so Sergio's asking, what if I had a square? Could I do -10x and -4x? We can't do that because this would not be a perfect square. These two need to be equal to each other in order for this to be a square. Otherwise, it would be a rectangle. But you're right, you can evenly distribute the -14x. This way, it's just not going to be a perfect square. Yeah, good question. Any other questions before we move on? All right, step number 3. Now I'm going to I'm doing step 2 now. Find the sides of the box. So I think I know what number goes here and here. Anyone else want to give it a shot? Only Andres and Fernando and Sergio. What number goes here and here? The sides of the box. It's pretty straightforward. You're just going backwards. Go for it, Cone. There it is. Everyone put it down. X and X. Cone, I have your card now. And here's another question. What goes here and here? It has to be the same number because it's a perfect square. This number and this number must be the same. Who has it? Jenny.
-7.
-7, yeah, you got it. -7. Thank you, Jenny. All right, we just did step 2. We're on to step number 3. I need to find this number. By finding this number, I think everyone can probably do it in here. By finding this number, we will complete the square. Notice that I have a square. X squared minus 7x minus 7x. And once I find this thing, this will be a square. But I need to complete that square by finding this missing number. By finding that missing number, -7 times -7, if I add that to the square, I have now completed it. Got it?
49.
It is
49.
Is it negative or positive?
Wait, positive 49.
Why is it positive?
Because 2 negative equal positive.
When you multiply. Exactly. Yeah, thank you, Gunnar. Everyone write down. 49 will complete the square. And we'll write down Gunnar's step right here as well. Find the number that completes the square. I can't spell. And then finally, we don't have to do this for example 1 because we're basically done. The answer is, what is the missing constant term? That constant term that we were looking for was 49. So our answer, we'll write it down and box it, was 49. We need to do step 4 in example 2, and I'll write that down for us. So make sure that the equation or function is balanced. That means if I do something to the left, I also do it to the right. I add maybe 49 to both sides. Or if I'm only dealing with the right, I have to add and subtract 49 to one side to make sure that it's balanced. Let's see how example 2 works out. So now I'm actually completing the square to solve a problem. I'm not going to actually solve the problem yet. This is just setting it up to complete the square. So rewrite the equation by completing the square. Notice that I'm rewriting an equation here, but on the next problem I'm rewriting a function. This function has everything on one side. This equation has things on both sides. There is a distinction between those two. All right, so let's ignore this plus 3 for a sec. Let's only look at this x squared minus 6x. So could everyone just box this? X squared minus 6x. Let's only pay attention to the terms that have an x in it. And we're going to complete the square for those terms. So again, I write out my square. Someone help me with the steps. The same steps over and over for completing the square. Step number 1. Somewhere x squared and minus 6x, they have to go inside the square in one of those 4 boxes. Only one person knows. 2 people know. 3 people know. 4 people know. Jose.
So the 2 squared goes on the top.
Or the x squared?
Yeah, X squared.
Okay, and finally, what else?
Negative 6x on the right.
Like right here?
Yeah.
Careful. So notice that this negative 6x has to be distributed evenly among these 2 spots. So divide it by 2.
Oh, negative 3x.
Negative 3x, and down here I'll have a...
Negative 3x.
Yeah, thank you, Jose. That's step 1. All right, I'm on to step 2. What's step 2? One person knows. 2 people know. 3 people know. 4, 5, Jessica. Okay. Perfect. Thank you, Jessica. And I should have your card now. That was step number 2. We're on to step number 3. We're completing the square. This is the step that Gunnar did last time. I need to finally figure out this thing that will complete the square. Sergio. 9. Everyone write it down. 9. But what this means is I need to add 9, or I have to put 9 on both sides. This 9 wasn't there before. Inside this blue rectangle, everything here is represented in these 3 spots. This x squared minus 6x is x squared minus 3x minus 3x. The thing that we're adding now by completing the square is adding a 9, which means in our equation, I'm going to have to add a 9. I'm going to rewrite it. Get ready to do this. This is really doing step 4. I'm making sure that the equation is balanced. I'm rewriting this equation. This equation is rewritten as x squared minus 6x. I'm just rewriting it, x squared minus 6x. Finally, I'm going to add 9 to this. I'm adding 9, and now this thing right here is a perfect square, but I have to keep rewriting the rest of the equation. I still have this plus 3 equal to 0, so I'll keep rewriting that. That's going to be plus 3 is equal to 0. There's a problem. I did not keep both sides balanced. Someone tell me why. Has to do with this black positive 9. Why did I not balance my equation? All right, so I'm asking the question poorly, but what I've done here is I've added 9 to the left-hand side. I've added 9, but I haven't done anything to the right-hand side. So what do I need to do to the right-hand side in order to keep it balanced? Andres?
So you add 9.
I need to,
on the other side.
exactly, I need to add 9 to the other side as well. So everyone write it down. If I add 9 to the left, I'm adding 9 to the right. This plus 9 came from nowhere. Well, I guess it technically came from completing the square, but I need to add it to both sides to make sure that I still have a balanced equation. All right, and here's a cool little trick. When I have to write this as something plus something squared, if I need to find this missing number, that missing number is going to be the side of the square. This is x minus 3, so this is going to be x plus a negative 3. Our answer here is negative 3. Everyone write it down. The answer here is the side of the square. And I'll write this down as well. This number that we found right here was the side of the square. Literally what I'm doing here is I'm rewriting this blue parentheses right here, and I'm saying this blue parentheses is now x minus 3 quantity squared. If you actually did x minus 3 times x minus 3, that's going forwards. That's saying x minus 3 times x minus 3 is x squared minus 6x plus 9, is x squared minus 6x plus 9. These two things here and here are the exact same thing because we've done the general rectangle. All right, there's one final thing. This plus 3 wasn't in this original equation. I now need to get rid of this plus 3 by moving it to the right-hand side. So, quiet raise hand. What do we do to both sides to get rid of this plus 3? Fernando.
Minus 3.
There it is. Minus 3 to both sides, and I'm left with 6 on the right-hand side, and I'm left with x minus 3 squared on the left-hand side. So the final answer is x minus 3 quantity squared is equal to 6. All right, this is a perfect time to ask questions. Jose, go for it.
Do you have to keep the 0 there?
Do I have to keep the 0 right here?
Yeah, or just be plus 9 or 9.
Oh yeah, so you do add 9 to both. I mean, you do copy down the original equation. Then we added 9 because we had to add 9 to both sides. So I guess I'm not sure how to answer the question. Just make sure that you copy down the equation, do the same thing to both sides, and then make sure that this positive 3 was canceled out. Did that answer the question, or am I?
Do you have to have the 0 there, or just?
Well, sometimes on Khan Academy they'll put like a 3 there, or just some other number. They don't give you a 0. That 0 is just random.
Oh.
Andres?
So you have to put x plus or x minus 3 to the quantity squared instead of like x squared minus 6x plus 9. Like,
Yes, yeah. You do have to write this x minus 3 quantity squared.
but you, like, why can't you do the other one?
Why can't you write it this way?
Yeah.
Because what we eventually want to do is we want to square root both sides. The trouble with solving x squared minus 6x is how do you solve for x? And there isn't really a nice way to solve because you'll have 1x squared and a 6x. There are two different powers. There's 1 to a power of 2, 1 to a power of 1. The only way to solve it is by completing the square and then taking the square root. That'll cancel out the 2, cancel out the square root, and then I can just solve for that x. So the strategy is something squared. Yeah, good question. Any other questions? Andres again.
So can I donate my vote to Julian?
You cannot. All right, let's go to example number 3. This is slightly different, but again, it's a completing the square problem. All right, so I'm completing the square, so I'm going to write out the square. Someone help me with step 1. Go for it, Fernando.
So x to x squared, but and then 3x and 3x.
I guess I don't really need the plus. Yeah, thank you, Fernando. That was step 1. And I just want to point out something that Fernando did correctly that he didn't mention. We're only using the x terms. This plus 90, that was just some random number that I decided to choose. So that plus 90, I'm going to have to deal with him later to figure out what goes here. But for now, ignore the plus 90 and complete the square for x squared plus 6x. All right, step 2. One person knows. 2 people know. 3 people know. 4 people. Josie, go for it. Okay.
3.
X plus 3, x plus 3. There it is. Thank you, Josie. And can someone please complete the square now? Jessica? There it is, 9. And that 9 is very special. So normally if I had an equation, I would add that 9 to both sides. So thank you, Jessica. But because I don't have access to this left-hand side is locked up because I'm saying y equals or f of x equals blah, 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 blah. That means this 9, I'm going to have to add it and subtract it at the same time to this right-hand side. I'm going to add 9 and subtract 9 at the same time. This leaves the equation balanced. If I add 1 and subtract 1, I really am not doing anything. It's still balanced. So what I have now is I'm going to rewrite this expression. I now have f of x is equal to, I'm going to rewrite this x squared plus 6x. X squared plus 6x. And here is the key. I now have this plus 9. Jessica's plus 9 by completing the square is now completing this square right here. But I still need to rewrite this other stuff that I haven't touched yet, this 90 and minus 9. So what is 90 minus 9? Can we just combine those into one term or one number? 90 minus 9 is what? 81? All right. Plus 81. I'm going to draw arrows so that people can follow what just happened there. So this x squared plus 6x plus 9, these first 3 terms made our perfect square. This x squared plus 6x plus 9 is a perfect square. But now I'm going to rewrite this. This f of x is equal to something squared plus 81. This 81 is not going to change. What goes on the inside here? And I gave you guys a hint looking at some part of this this box method. What goes on the inside of this perfect square now? Gunnar.
X plus 6.
Ooh, careful.
Wait. Oh, 3.
There it is. X plus 3, quantity squared. Thank you, Gunnar. Again, to find this inside right here, look at the side. Look at the side of the square. All right, so on Khan Academy, we only have, I think we have 2 assignments. One of them is pretty straightforward. It's kind of like example 1 where you just have to find that constant. And then the second assignment is a little bit harder. Half of the questions are like example 2, half the questions are like example 3. So there's always the question, what do I do? Do I add and subtract to the same side? Do I add to both sides? What am I supposed to do? Andres?
So, why would you put plus 9 and then minus 9?
So in order to keep this equation balanced, if I just add 9, I would love to just add 9 to both sides. Like plus 9 right here, plus 9 right here. But I can't add 9 to f of x because f of x is the function. So I can only work with one side. If I can only work with one side, I have to keep it balanced by adding 0 to it. If I add 0, it's still balanced. So what I'm really doing is adding 9, subtracting 9. It's still balanced. That plus 9 is being absorbed by this x squared plus 6x to complete the square, and then what's remaining is this 90 and this negative 9. It's all about what you have access to. Normally we have access to both sides. This is a case where we only have access to one side. So, and that's kind of encompassed in this little section down here. So if terms are on only one side, so it's like a function, this was where we had terms only on one side, then do what and what for that constant that completes a square. What did we do with this 9? There it is. Add and subtract. But what if the equation, what if I have terms on both sides, on two sides? Then I'm dealing with an equation, like example number 2. Then what do I do with that constant to both sides? Gunnar? Yeah, just add them to both sides. Add to both sides, or just add and subtract to one side. All right. And I want to give as much time as possible for the practice. So that's the end of the notes. So there's a lot of things that you can have in your summary. You don't need everything, just get the important stuff. So I would say that the most important thing is the procedure for how to complete the square. Can you make your own problem for the exam or the summary, or can you write these steps for the summary? Do something nice, quick, and efficient for the summary. This procedure is probably one of the most important things that you can have. All right, and that completes the notes.